Greetings! Today I'd like to show you the steering mechanism for the dish, for my 10 GHz tower mounted system. You've seen this actuator in a previous video. I've finally found a way to make it orient the dish, and of course you have to attach part of it to the actual dish and part of it to something that's fixed to the mast, and that's what I did here. I use an aluminum tubing that's fastened to the main mast, and that's fixed, attached to the tower. Actually will be attached to the main rotator, of course, and then the dish will be rotating on its mount. So normally that part here is tight and hard on the main mast itself, and the dish cannot rotate on this axis. But in this case I won't be tightening up the screws, and I've added some grease. I've greased up the actual mast itself, and now it's free to rotate on this axis. Now, in order for the dish not to come out and drop 40 feet down from the tower, I've also added a 9 bolt. This bolt goes through this bolt here. This is the long thing, and I have a plate here with a couple of bolts that will hold the dish from coming out of the main mast. And this is how I will keep the dish mounted to the mast, because normally this whole thing is rotated upside, okay? And now I've rotated upside down, and that's the configuration that I want on my tower. This part here will get attached to the main mast on the tower itself, and that's being turned by the main rotator, the tail twister. This will be fixed to the main mast, and this part here will come down, and then the dish will be able to rotate around this mast here. So this is why my aluminum tubing here is attached to the main mast. It's tightened, so it's fixed, and that's my reference point. And the actuator pushes or pulls on the dish here, which makes it rotate around the mast. So it's a simple system, and it works fine. So here's a demo. So the main challenge for this actuator is to have this plane here, okay, the plate to which the actuator is attached, parallel or in the same plane as the aluminum tubing here, because this hole here, so this shaft has to be parallel to this bolt here. So you need to position the tubing here on the mast in the right location so that these parallel axes are met. And this pretty much sets the height also of the dish and the shimming that I've put here so that everything is parallel. There is no doubt in my mind that this is the weak point of the entire system. In the summertime, I'm pretty sure it's going to work fine. In the wintertime, remains to be seen with ice, snow, and everything else, which are going to fall on the entire thing over time. Makes me wonder, really makes me wonder. We'll see how it goes. Worst case, I just quit operating after an ice storm, and that's it. I'm not going to be very active with this system anyway. There is a little bit of a loose here, and it's accumulation of tolerances on this bolt, the actual actuator itself, there is some slack here, and this bolt here, which also has a little bit of slack on the shaft. And these loose parts add up to about 1 increment in the opposite direction. Say I'm pulling the dish in that direction, it's going to be a tight adjustment. But if I decide to go the opposite way, I'll have to press 1 major move in the opposite direction, and that move in the opposite direction will catch up on the slack, and then the next increments opposite will move very smoothly. So something that I know when I will operate the thing to aim at the station, I will know that fact. And it's very difficult to make it perfectly tight and without any slack to catch up. Even the actuator itself has some built-in, and it's not possible to completely eliminate it. It will work fine for my situation. The actuator is rated to be weatherproof, but I have doubt about this here. Over time, water will probably creep in. Remains to be seen. I'm not very confident about that. As with the rest of the project, I've used recovered pieces of aluminum that I've machined myself, and stainless steel hardware almost everywhere, even here. The only part is not stainless is this U-bolt here, but it's pretty much all stainless. This will help over time, of course. Alright, so much for the dish steering. In the next video, I'll show you the feed point assembly and the radome to protect it. Until then, 7-3.